In this video, I'll explain how to write a vector in terms of magnitude and direction. That assumes you've been given the vector in components. How to write a vector as magnitude and direction. Last time we started with the notation, and this one everybody pretty much agrees with. You can write the vector v as the magnitude at an angle of theta, and usually that angle theta is given with respect to the horizontal, or if you think of your coordinate axis, which I'll draw in just a second here, with respect to the x-axis. So again, a quick sketch of my coordinate system. This is usually my x, this is usually my y. Now, in terms of polar coordinates, you write a vector in terms of r and theta. If we're going to use the vector v, again, same vector, same notation I used last time, the magnitude is the length, and the other piece that you need for magnitude and direction is this theta. So if what you're given is the x and the y components, so if you're given vx, which would be this piece, we had the same picture last time, and vy, which would be this piece. Notice I've drawn them like vectors head to toe, so it's like adding vectors too, if you've already talked about that. So the vx and the vy, if that's what you're given, how do you get the magnitude and direction? So given the x component, vx, and the y component, so given vx and vy, how do you get, given the vx and the vy, how do you get the magnitude, which is the v, magnitude, v, and direction, which in this case we're just specifying by the theta. If you don't specify anything else, that is the default, is that it's given with respect to the x-axis and goes in the positive direction. So if you don't specify, the theta starts here and goes towards the vector in question, which in this case was the vector we're calling v. You can use the Pythagorean theorem to figure out the magnitude. Remember the Pythagorean theorem? The Pythagorean theorem, usually you draw a triangle and you label the sides A, B, and C, and usually C is the long side. So A, B, and C, and then the Pythagorean theorem says that A squared plus B squared equals C squared. You can do exactly the same thing. So if you want the magnitude, in my notation, again, I use the vector with no arrow over the top of it to mean this. You might remember that two parallel lines around something in math means the magnitude. So the two parallel lines mean the magnitude, but I don't want to write that all the time. So for any quantity that's a vector, and I don't write it with a vector arrow over the top, that means I'm thinking about the magnitude. And that would equal, for our triangle, the two short sides are the vx and the vy. So we square those, vx squared plus vy squared, but that would give us v squared. So the magnitude is actually the square root of that whole quantity of the vx squared plus the vy squared. That's how you get v if you're given that's how you get the magnitude if you're given the x and the y components. To get the direction, which is to get the theta, you use trig, and if you remember from trig, the tangent of theta is given by the opposite side over the adjacent side. If you go back up and look at our triangle, the opposite side of the theta is the y side, so this is the opposite side, and this is the adjacent side. It's the side that actually touches the theta on one side. So it touches the angle theta on one side, that makes it the adjacent side. So our opposite over adjacent gives us the vy over vx. And then, of course, you can take the inverse tangent if what you want is theta. So to get the actual theta, you take the inverse tangent of Vy over Vx. That's it. So that is the direction, and the square root gives you the magnitude. Let's do a very quick example. My favorite one that I use a lot is that a person walks 4 miles east and then 3 miles north. 4 miles east and then 3 miles north. So those are basically the components of a either distance or displacement. Quick sketch here. So you do your 4 miles east, a little bit too far. Let's make it 4 squares. 4 squares east and then 3 squares north. And you want to know the magnitude of that. So put your vectors head to toe, so the final displacement would be this vector here, which we don't quite know what it is, so we're going to figure that out, the magnitude direction. So this is your 4 miles, this is your 3 miles, which are exactly like the picture for my x and my y components, and then v will be the magnitude of this, and we can use the tangent to find the theta. So it's pretty straightforward. The v is going to be the square root of the vx squared plus the vy squared, which is the same thing as the square root of the 4 squared plus the 3 squared. Both of those are miles. Running off the edge of the page, sorry about that. When you square those, they work out very nicely. You get 16 plus 9. Both of those are miles squared, still under the square root. And then 16 plus 9 is 25. And you might know the square root of 25 is 5. So the magnitude of that is 5 miles. It's one of my favorite triangles, the 3, 4, 5 right triangle. I use it a lot. And then the last thing, we need 2 pieces of information always for a 2D vector. So the last thing is that we need to get that angle. And so the tangent of theta is the opposite side, which is the 3 miles, over the adjacent side, which is the 4 miles. Miles cancel. Anything inside the tangent, or the tangent of the angle, anything there has to be unitless. So the units cancel, so that's good. So the theta is the inverse tangent of 3 over 4. Plug that into your calculator, and that turns out to be 36.9 degrees. So I would write, for this final, if somebody asked me to write that vector, I would write that, I might call that a delta r. I never really gave that a name. And the displacement could be 5 miles at an angle of 36.9 degrees. Is just using the wording of the problem. You could actually leave it just at that for most problems in class, but since they gave you the wording of the problem, I might say north of east. It is the standard angle and the standard north, south, east, west that people usually draw on paper, so that's probably clear enough.